Hello, future engineers, subscribers, viewers, and students. Here is another video about solutions to two problems in statics, particularly on 2D equilibrium. So here is the first problem. This is very basic. In the figure shown, force P is applied to a small wheel that is free to move on cable ACB. So it's free to move. For a cable tension of 900 newtons, find P and theta. So take note, this wheel, small wheel, is free to rotate. So meaning frictional resistance is negligible, and the tension on each side of the small wheel, the tension in this cable is the same. So that is 900 newtons there, 900 newtons. So this is now the free body diagram. So we have 900 newtons along this cable, AC, and along BC we have 900 newtons. The angle is equal to this angle 30 degrees, and that angle is also that angle 45 degrees. So applying uh, equation of statics, summation forces X equals 0, so the X component of P is P sine theta, then plus the X component of this 900 Newton force, 900 cosine 45 degrees, and equals the leftward component of 900, which is 900 cosine of 30. Simplifying, P sine theta equals 900 cosine 30 minus 900 cosine 45 degrees. That would be 143.03. Call that equation 1. Summation forces y equals 0. So we use downward component, vertical downward component of P is equal to upward components. So P cosine theta, downward component, equals upward component. So one component is 900 sine 45 degrees, the other plus 900 sine of 30 degrees. Combining again, P cosine theta equals 1086.4. So that's equation 2. To solve for theta, we divide equation 1 by equation 2. So equation 1 divided by, that's equation 1, the right side equal over equation 2 of the right side. Cancel out P, this is tangent of theta equals 140.03 over 1086.4. So theta is inverse tangent of quantity 140.03 over 1086.4. From there, we get theta at 7.501 degrees. Having known theta, we substitute this value into equation 2. So P cosine 7.501 degrees is equal to 1086.4. Solving for PP is 1096 when rounded off to 4 significant figures. Then for the second part, in the figure shown, the cord passes over a pulley at C and supports block D of mass 15 kilograms in contact with the uniform bar AB with mass 10 kilograms. So find the horizontal and vertical components of the force at A, that is AX and AY, on bar AB, and the force exerted on the bar at B. So the contact force between D and this horizontal bar B. So we will denote the tension in the cable here as T. Again, the tension on the sides, the same. So that is T, that is also T, T, T. So meaning if we cut that part, this is now the free body diagram. So we have T here, and this one, let's draw the free body diagram of this uh, box or block. So we have here the tension P, the weight of the block 15 times 9.81, so we have 147.15 newtons, and the contact reaction between this block B and the bar. So I'll call that ND. Of course, we expect compression, because if you put your foot over that block D, it will be pressed, so compression like that. Summation versus vertical equals 0. It is ND plus T equals 15 times 9.81, and that is 147.15. The contact resistance between block D and the horizontal bar therefore is equal to ND, and it is 147.15 minus T. Then we consider the free body diagram of the bar AB. This is now the free body diagram, complete, AX, AY. Then the normal contact reaction between D and the bar, 147.15 minus T. The weight of the horizontal bar is 10 kilograms times 9.51, so 98.1 newtons, and it is acting at the center. Half of 8 is 4 meters. Then, that's it. So, summation of moments about A equals 0. Only the vertical component of T has moment, the horizontal passes through A. So, the vertical component T times 3/5, and the moment arm distance from B to A is 8 meters, 2 plus 6, then equals clockwise moments. Clockwise moments are quantity 147.15 minus T times 2 and plus 98.1 times 4. Simplifying, we have 2.4 over 5, 224 over 5 rather, plus 2, that's 4.80, plus 2t is 6.80. Then combining 147.15 times 2 and plus 98.1 times 4, that right side is 686.7. So t therefore cannot be computed, 686.7 over 6.8. So T is 101 newtons. Solve for AX, summation forces horizontal equals 0. So AX to the right equals the X component of T, which is 101 times cosine of theta 4/5. So AX can now be solved, 80.80 newtons to 4 significant figures. Likewise, summation forces Y is equal to 0. So we have AY plus 101 times 3 over 5 for T sine of theta, T 101 sine theta 3/5, then equals downward forces 147.15 minus T, then plus 98.1. Solving for AY is 83.65 newtons, and it is upward as directed. And finally, to solve for ND is already given by this expression, 147.15 minus T. So 147.15 minus 101, we get ND equals 46.15. 147.15 minus 101 is 46.15. So that's it for this video. I hope that you were able to follow the explanations and the solutions.